Nuclear energy is extracted through a process called nuclear fission, in which the nucleus of an atom is split into two or more smaller nuclei, along with a few neutrons and a large amount of energy. The most commonly used fuel for nuclear fission is uranium-235. When a uranium-235 atom absorbs a neutron, it becomes unstable and splits into two lighter elements, such as barium and krypton, releasing energy in the form of heat. This heat is used to generate electricity in nuclear power plants. The process begins with the mining of uranium ore from the earth. The ore is then refined and processed into fuel pellets that are stacked into long rods, known as fuel rods. These rods are assembled into what is called a fuel assembly and placed into the reactor core. Inside the reactor, the fuel rods are bombarded with neutrons, causing the uranium atoms to undergo fission and release energy. The heat generated from fission is used to convert water into steam within the reactor. This high-pressure steam is then directed to spin turbines connected to generators, producing electricity. Control rods, made of materials that absorb neutrons, are inserted or withdrawn from the reactor core to regulate the rate of the fission reaction and ensure the process remains stable and safe. These control rods are crucial in maintaining a consistent production of energy and preventing the reactor from overheating. The entire process is conducted within a containment structure designed to withstand extreme temperatures and pressures, as well as to prevent the release of radioactive materials. Once the fuel rods become less efficient for generating power, they are removed from the reactor and stored in cooling pools to reduce their radioactivity and temperature. Eventually, they are either reprocessed to extract usable materials or stored in long-term disposal facilities. Nuclear energy provides a significant amount of electricity without emitting greenhouse gases during operation, making it an important component in efforts to combat climate change. However, the disposal of radioactive waste and the potential for nuclear accidents remain challenges that require careful management.